All right. Well, you know what? I'm gonna say let's start it off. It's 6:03. I still see some folks are coming in, but let's do this. First, I want to say thank you so much for joining me tonight for the November edition of the Pinellas Tech Network Meetup, or PTN, as we like to call it for short. The PTN started in way back in 2018 now, and we started as an in-person event, but then we moved virtually somewhere around, geez, I don't know, maybe October of 2020. But we're located in Pinellas County, Florida, which is in the Tampa Bay area. It's kind of north of St. Pete and it's west of Tampa, right near Clearwater and Tarpon Springs. Um, my company is called Geographic Solutions. They are super cool and they let me do this night. And we, at some point we'll get back in person where we will have like, free food, a really cool room where we have these events. And but until then, I'm here with my fun DJ light behind me and just doing my thing. But Geographic Solutions is a company that helps folks on their career journey, and we specialize in developing and maintaining online SaaS solutions for workforce development, economic development, education, corrections, human services, unemployment insurance, and a lot more. So at the end, I'll throw up a link and you can check us out. But the reason why we're here tonight is because I'd like to introduce Lubosz Kosnik, and I hope I got that right. Lubosz is a software engineer at the one-click checkout platform Fast. He's going to talk about his experiences with scaling microservices architecture. And without further ado, Lubosz, welcome. Thank you so much for taking some time tonight to be with us.
Hey, hello everyone, and thank you for invitation. So, as you said, I'm Lubosz. I'm a software engineer and SRE in Fast. On the right-hand side, you can see our product. Without starting about, like, we have to start to understand fully why we've done what we've done. We have to start with our product. As you said, we are a one-click checkout solution, but it's not only fast by the name, it's also a design feature. It has to be fast, it has to be secure. The thing is that we're moving money, we're moving products between the clients, between the stores. So a lot of what we've done was created specifically to fulfill those requirements. Example, microservice architecture. Like, we can come up with tons of and thousands of them. Each one will be specific to the company, and this is something what I found when I joined the company. So because, as I said, because of the security requirements, because of the performance requirements, we had Cloudflare at the front of our infrastructure. From the Cloudflare, we were sending traffic to AWS clouds, to application load balancers, and then they were pointing to the Nginx ingress controllers deployed inside our infrastructure. By doing this, we were able to implement a blue-green methodology for deployments, which, like, if you know, blue-green, the major con of having a blue-green is having to pay double the price of your infrastructure. You have to have a full infrastructure deployed twice. The second important problem is doing deployments. With this architecture, we had a huge problem that we had to do, a thing called Big Bang. Like, we had to deploy everything. If something was going wrong, we had a quick option of reverting to the previous color of the deployment, but it still was creating a huge problem. Because of the security reasons, our front-end services, they use GraphQL. So they were talking to Apollo servers deployed in our infrastructure. But again, because of the blue-green deployment and because of the security and additional features provided by the Cloudflare, we had a huge problem with Apollo having to talk through Cloudflare back to our infrastructure, to the Envoy services, which we're doing transcoding. Our backend services, they all use gRPC for communication. It was specifically selected and designed for performance, but it was creating this disconnect between the front end, between the backends, that they are using different protocols, they are using different technologies to fulfill their requirements, and because of that, we started having problems. So when I joined the company, the things I identified as a problems were basically this whole architectural design. Like the front end was doing one thing, they were going constantly across the board, across the boundaries of the AWS. They were going to Cloudflare, which was creating a huge latency. And as I said, the fast is not only the name of the company, that's the design feature of the system which we're doing. So that really means that, like, first of all, like even the microservice architecture, we are having front end which uses different technologies. It uses different languages. We have backend services which are talking different protocol, and we have a lot of services. Currently, probably we have around 20 services on the backend just to fulfill a simple checkout solution, which is not as simple. So what we found, we have to be secure, we have to be safe. We're moving money, we're moving people's data, and the statute and the policy for our company points one and the most important thing: we never ever gonna sell your data. We are not here to earn money on selling people's data, people's information. We are here to create the simplest and easiest checkout solution for anyone, for any store available online. So for us, it was really important: security, observability of the infrastructure, making infrastructure as much as possible self-managing, and most and like foremost, the latency. We had to decrease the latency of the communication. There's another very important aspect, blue-green deployments. Like, we couldn't afford having two duplicated copies of our infrastructure and risking with impacting each and every client whenever we were doing deployments. With scaling our systems, with scaling amount of engineers, we wanted to do more than single deployment of everything at the same time. So we had to come up with something. So first, we thought, okay, latency. We have to do something about the latency. The problem was simple, let's say. We had Apollo server, because of the blue-green deployment, because of those colors, had to go back and forth to the Cloudflare and back to the infrastructure. So we thought, okay, we have to do something about it. We selected, let's switch the simple blue-green deployment using Nginx ingress controller to something more sophisticated. We selected Istio. Istio is a service mesh for Kubernetes deployments, and this was really important from our perspective, because Kubernetes solves for us the problem of self-management and self-healing capabilities. So because our whole infrastructure, all services were deployed on Kubernetes, we selected Istio. By selecting the Istio, we didn't have any more problem with the blue-green deployment and having go back and forth to the Cloudflare and back to the infrastructure. we were able with Istio to configure the same redundancy, the same color changing capabilities directly inside. So what we thought about, okay, so if we have Istio brings a lot of logic into the kind of simple networks. So maybe we're gonna do something about it. So we come up with the plan that instead of having the blue-green deployments, because we're gonna have Istio for reducing the latency, we're gonna go a step further. And we selected and we thought, okay, let's go with the canary deployments. With the canary deployments, we didn't have any more problem with the big bang deployment of everything affecting all of the clients and everything. We're gonna have an option of possibly affecting, if there will be any problem with the deployment, we're gonna be affecting just a small percentage of the clients. We can add additional information, additional configuration into the Istio and specify, okay, just send 10% of the clients to the new version of the system. The next aspect, the security. Because our front end is using different technologies, our backend services are using different technologies, we had to come up with a way for securing our traffic and to have a unified way of managing the security of our traffic. So yet another time, Istio comes with help. And what Istio provides is basically automated and MTLS functionality for any service. They do generate certificates. They do generate SPIFFE certificates, which basically provide information about the originating service of the traffic. So because of that, we know each and every time that, first of all, the traffic comes from the inside of the cluster. It comes from the specific application. So because of that, we can drastically increase the security of our traffic, and we can verify and allow for the specific operations to be called by the specific services. So as I said, Istio was an extremely important and a building, like it was the ground building stone for everything what we've done. But it was not the only tool which we had to use. So because of the of our of the things which we're doing, like we're moving money, the observability and auditability is really important for anything we are doing. So we had to come up with something what's going to allow us to make those deployments in a safe, secure way, repeatable way, and they're going to leave a trace of information, what was done by whom. So we selected Spinnaker. Spinnaker is an enterprise-grade deployment service. It's a part of the Cloud Native Continuous Delivery project. It's created under the umbrella of the CNCF. So it's open source. It's sponsored by multiple companies, and it was built for working with the big amount of the deployments, supporting continuous deployments, continuous delivery. As the next step for the Spinnaker, it was a no-brainer for us. We had to do something. We had to build a configs for the Kubernetes for our deployments of our services. Spinnaker has a native implementation of supporting customize. Because of that, we thought, okay, let's go with the customize. It will allow us to build services, a deployment specifications in a standardized way. The thing about our services, because like we own and a lot of the backend services, they are using the same technology. Because of that, it was really easy for us to build a shared components, which then they are being upgraded by the specific applications, by the different environments, and they are easily to manage by us. The last but not least important piece was Bazel. Our company does use monorepo, which means that the whole source code of the company, all services, all applications, the protobuf specification for communication between the services, everything is shared in the same GitHub repo. To be able to support that size of repo, that size of amount of changes coming from developers, to be able to test this and build those systems and applications, we had to use something with scalable. So we are using Bazel, which does a great job of figuring out dependencies between the systems. And based on what changed in the current commit, it is able to build all of the dependencies with the finished applications, deploy them to the repositories, build images, Docker images, publish them, and make everything working in a scalable way. Yeah, and as I said, the customize gives us this option of building using the shared components. So it is making a really easy it makes really easy for us to configure Istio for specific services. And that's where the canary deployments come from. Customize allows us to build a shared configuration for application X for deployment to the production, but then by applying a simple changes, simple overrides on the ready production configuration for Istio, we can add additional configs to configure another set of pods, which are marked with the special label, meaning that this is a canary deployment of the application. And because of that, it allows us to send a small percentage of the traffic to that specific application. So it was like a logical chain for us. We had a monorepo. We were keeping all of the code in the same place. We were using the same repository with the constantly growing amount of the engineers. We had to build those systems. We had to test those systems in a scalable way. So we went with the enterprise grade product with Bazel. Because we were using Bazel, because of the amount of the builds, tests, and executions running daily, we had to go and come up with something what's going to be able to handle that amount of the builds, which going to be stable, which going to be manageable, which going to have observability built into. So we come up with the Spinnaker, because Spinnaker has a built-in functionality to support deployments of the application using customize, and has a native implementation to talk directly to the to GitHub, to be able to download the customized components, to download the customized configuration. We went with it, and because we had customized, we were able to easily configure Istio for multiple environments, for multiple systems, and because of having Istio available, we were able to build a canary deployment functionality for our engineers. As well, we also received a lot of functionalities like mutual TLS, so automated encryption of the traffic, functionality to be able to verify where the traffic is coming from, where based on this information we can configure that application A is able to call application B, but only this specific endpoint. So we have, for example, one of the systems, and this system handles secrets for other services. But the thing is that this service is not only handling this simple thing of having secrets. It has also a different APIs which are used by different services. By having Istio in place, we can configure that this service is able to call that service to get the secrets, but none of the other services deployed in our infrastructure, they are able to talk, and they are able to call that API endpoint to get the information. So for the Istio, this is example config file, and this is like basic to building stones for Istio configuration for canary deployments. So we do have a destination role, which is a custom resource definition for Kubernetes for Istio resource. It does specify that we have application called Hello World, and it does have two subsets. One subset is called V1, which Istio loads based on the label called version. If the version is V1, then Istio will load all of the paths marked with that version, with that label, and it will put them into the subset called V1. And the same for the V2. By doing and by aggregation of those services by the labels, it's really easy for us to even test multiple versions of the system. So with that functionality with Istio, we can deploy multiple versions of the same system and test them concurrently with each other. Because of the labels, we're using Datadog for collecting our metrics, our traces. And all of those labels attached and applied on the service, they are automatically exposed in Datadog. So because of that, we have easy way of comparing applications, specific application versions between each other. And because of that, we can see functional, like we can see right away information, for example, latency. Yet another thing which Istio brings is a great observability without dependency on the language used by to implement the system, the application. So by doing those things, we have a great visibility, and we can right away see and compare that version 1 of the application has a latency on the level of 100 milliseconds. The version 2 has a latency of 200 milliseconds, which automatically means, okay, we're gonna throw away version 2. It's unusable. The developer which was working on the functionality needs to figure it out what changed in the code was made that the latency increased in this new version. So because of that, we have a quicker iterations. We can quicker know that some implementation, some changes to the implementation to the service has been made, which creates problem with latency, with error rates, or other things. So on top of the destination roles, Istio uses the Virtual Service CRD, which does finalized version of routing. It does specify that whenever request goes to the Hello World endpoint, to the service on the Hello World domain, it has two routes to use. It has a Hello World version subset version 1, send 90% of the traffic to that version, and then destination Hello World version 2, send 10% of the traffic. By doing and by adjusting those weights, we can change how much traffic gonna go to the specific version of the system, of the application. So it does allow us to increase the percentage. And if someone is familiar with the Kubernetes, you know that normally by just having pods, it's really complicated to get weights correct, because Kubernetes makes the service uses round robin, and it will, like, basically you have to build and deploy application in specific percentage to be able to achieve this. With Istio, majority of our testing does require only a single part of the new version of the application, and we can still, our services are extremely efficient. So because of that, we can just spin up a new single pod for the new version with the rest of the services, rest of the pods running the previous version, and we can easily verify a higher percentage of the traffic going to the new version. So then customize. You can see the big white box. It specifies a deployment for the LDAP application. It has replicas specified as one, has all of the labels specified. And then we have a staging patch. On a staging patch, we just want to do a simple patching. We are just implementing and updating amount of the replicas. So the staging patch just specifies the same deployment for the LDAP with the replicas too. When we are gonna go to the production, we are yet again increasing the amount of the replicas, but also we are adding additional volume, which is just an empty directory. But because of that, we have an option of adjusting configurations, patching in a very, very simple way. We can patch and change backend services used, backend databases, anything can be added. But the nice feature of Customize also is that it can do any operation on the produced CRDs, or like the resource definitions. So it has also option of like removing things. Because of that, like there is no limits, there is no restriction on things which you can do. And because of that patching methodology, we have an option of using those shared components. So for example, Datadog has a lot of requirements about the additional labels which has to be applied on a service. We have a shared components which are loading them, and they are attaching them to each and every application we're deploying in our infrastructure. And the Spinnaker, Spinnaker UI, it's not the nicest, it's not the best, but the whole system is really stable. We are using that system for almost a year already, and we never had a single problem with the system. We didn't really had to scale it much in a standard deployment. In a standard version, we are using a special operator for installing the Spinnaker in our Kubernetes clusters. We never had any problems, and it really suits everything and all of our needs. We are using webhooks to call to the Spinnaker to trigger specific pipelines. But the nice thing and the really important thing for us was that majority of our systems and our deployments, they use Kubernetes, but we also have a serverless infrastructure behind. So whenever we have a checkout flow at the end of the original flow, we do have backend processing done by the serverless systems. And because Spinnaker allows us first manage deployments to the Kubernetes, but it also has a really good implementation for supporting AWS resources. So because of that, we are able to deploy more than just Kubernetes deployments. We can manage AWS infrastructure using Spinnaker and deploy serverless systems in AWS using this system. So in conclusion, we redone our architecture drastically. Like we changed everything from the deployment perspective, from the service mesh, like bringing service mesh into infrastructure. It's a huge, like if anyone done those things, you know that it's huge, and it's a huge operation requiring a lot of work, a lot of cooperation between the teams. But if you're gonna choose a good tools, if you're gonna choose a tools which are stable, which are done by a lot of the good companies and good engineers, you can make it working. So thank you so much. And any questions?
Hey, Lubosz. Yes, we have quite a few questions, and so thank you so much for this detailed presentation. Um, I'm going to do two things. One, we got a couple questions here. Akmal, I don't know if I'm pronouncing that right, but I would like to, if you want, I can unmute you. It looks like you're self-muted, but if you want to go ahead and just ask your questions, or I can ask them for you. It's up to you. Um, Lubosz, I'm going to go ahead and make you an organizer so that you can see some of the questions along with me. So give me 1 second here.
Sure.
Hello, can you hear me?
Hey, yes, how's it going?
Oh, I'm sorry. I didn't know that there's an option to unmute. Oh, thank you very much. Everything you taught me everything is new. I never heard about anything. So I have
Okay.
a team. So I have a team. We're trying to create our own microservice. So that's why I'm looking for the options. So the main question I have is, we will have this microservices, a lot of microservices, but I think that the data might lose in one of them when you're sending. So we wanted to know what is the options you can keep that data so the
So this
messages
is
are not lost.
So this is why we selected Istio. You really have to go and look into service mesh options. Istio gives you an option of monitoring, like first of all, it's a service mesh. It does give you the security, but also it generates traffic information. It generates metrics for the whole traffic going through the service mesh. So by doing this, first of all, you're getting information about the traffic, but also they have an additional option of distinguishing a traffic based on a observability from the sender perspective and from the receiver perspective. So because of that, with Istio, you can build a dashboard which gonna show you this is the amount of the traffic which some services send to me, but this is the amount of the traffic I'm receiving. And the same thing you can do for latency, for example. So you can see what latency the origination server sees and what latency you're seeing. So you can, by doing this, you can see the difference. Like you can see a networking lag and all of those information, which basically gives you an option of seeing if you're losing any traffic, somewhere inside of your infrastructure on your network.
Thank you. I'll come back. I'll just wait for my queue.
Awesome. Okay, and so now I want to go to Lloyd, who has a few questions. And Lloyd, I would like to say if you want to go ahead and unmute and go right ahead.
So I'll try. Can you hear me?
Yeah.
Yep.
Awesome. Okay. Lubosz, good job. So we have been looking at Istio for a while, and the thing that I don't understand well enough, maybe you can teach me, is how you're handling the end user identity. Is it being passed all the way through to the backend services through Istio? Is Istio making decisions based on those identities? Or are you really just looking at service to service identities? Talk to me more about how you're handling that.
Sure. So for us, like the thing is that before we brought Istio, we were already using Envoy. We were using Envoy as a standalone service, which was allowing us to enforce the authorization. But what we've done for our specific use case, we do have a service, our own internal service, our own private service, which is responsible for the access management. And what we've done with Envoy and what we're gonna be doing with Istio in the near future, because this whole process didn't end yet for us. For what we're doing is we're using Envoy / we're gonna be using Istio for calling external authorization system to verify the person. And because of that, you have an option of like adding additional information. So for us, like we're doing an authorization, we're setting up the cookie, which then as the part of our each microservice system which we do have additional module built which does allow to verify sessions in this authorization system. The small module takes the cookie, takes the session, all of the information about your session, and verifies this with the global authorization system.
Got it. So that works at the very front edge, but are you then passing that cookie all the way through service to service, and is each service making its own authorization decision?
So each service does verify the session. As I said, we have this small module which is running. So because we're using gRPC, our team we've built a set of interceptors for the gRPC servers, and our identity management team, they came up with this small module. So we're running this small module as a part of our interceptors, as the part of the server, and each one of the servers does verify if you're supposed to be able to see this, because our own microservice is responsible, for a different set of features and functionalities, and we do support, enterprise companies. So, for example, we have a situations that one of the things is just providing an option of doing checkout. So for doing checkout, there is not much things to verify. But then, for example, if the enterprise company, they have, for example, an employee who's able to refund clients. So for doing those things, the system needs to go through multiple systems, and because of that, each and every one of the systems does authorization of you in a IAM system.
Got it. So Istio is not really helping you in that regard, which is kind of the conclusion I came to as well. Thank you for this.
So it's not that it doesn't help, because we still, like, the Istio gives us option of, first of all, filtering out the traffic, as you said, like service to service communication, but also it does simplify for us and does allow us from a higher level to manage and verify those credentials, because you can't get to the application if you're not going to go through Istio. If you can't go without Istio to the service, we can add additional logic like observability, but also the authorization. So
yeah,
as I
sorry,
said, like
I misspoke. It's not helping you in terms of the authorization part at the service level, but yeah, I get it that there's all kinds
yep.
of other benefits.
Yep.
Yep. Okay. Perfect. Thank you.
Sure.
Thank you, Lloyd. And Akmal, we'll go back to your next question in a second, but I'd like to go to Thomas. If Thomas is out there, Thomas had a few questions.
Yeah,
Yeah,
just to
hey.
say,
How's it going?
Hey, it's going good. And good night to both of you. Thanks for the talk this evening.
Thank you for coming.
You gave us part of the story where we get to see a 10% canary deploy. What happens after this? And is there tests that go on to assure the quality of the new deploy? And then the service becomes live to 100% with the new deploy and the old deploy spins down. What happens during this time period? And is this all automated?
So currently the deployment of the 10% is automated. After that, unfortunately, because we didn't, like our team is small, we didn't automate yet. We do have plans already. So one of the reasons why we selected Spinnaker, Spinnaker has a plugin called Kayenta, and Kayenta is a system for doing automated canary deployment. The automated canary analysis. So as I said, we are using Datadog. We are publishing and marking data for an each version of the system, also for the information that this is a canary version of the system. So because of that, we are looking and we're going to be rolling out Kayenta, which will be able to take from the Datadog information. Okay, give me latency information about the canary. Give me information about the latency for the normal version / baseline, and it's going to be able to compare them with each other and make another decision. So we are not done with this whole thing. We are still working and we are still adding another things and another features. So we are gonna be adding this this system. We're gonna be adding also an automated integration tests and other things on top of this functionality, or not on top of that that system. But we are not done yet.
Okay, awesome. Thank you. Sounds like you're a small team, but you're doing a lot of really cool stuff.
Yep, that's for sure.
Excellent. Thank you, Thomas, and thank you, Lubosz. I appreciate you answering. I want to go back to Akmal now. If you are still on and you want to ask your next question, go ahead. And I just wanted to throw this out there to anybody who wanted to ask a question, pop it in the question window, and let's discuss it. We have until about 7 p.m.
Yeah, thank you very much. I feel like I'm the least knowledgeable here. The questions are very simple. So the question was, I'm new to microservice. We're moving from AppSync. Everything was on AppSync. We're trying to move anywhere from AppSync. So we're just trying to understand how microservices work. And now we're having the problem of dividing the data. Like we had like students and teachers, and we don't know whether we put them together in one table or we need to separate them in MongoDB or any other things. Just how to separate all data. It's so confusing for us to understand.
I know, like the main thing and the main problem about the microservice architecture is that you can really come up with multiple versions of it. Everything will be depending really on a person's working on it, on people working on it. Also, you have to take into consideration what your available, amount of people, how much work you can put into it. The really important thing about microservices is that it will drastically affect your latency, because normally, with the monolith, everything is running inside the same process, probably on the same, CPU, sharing the same memory. With going to the microservice architecture, you're gonna drastically decrease the latency of your system. So because of that, you have to think about like how much you can divide the system into pieces without really affecting too much clients, and also how your company is divided. Do you have a specific teams which are working on a specific features, or do you have an organization group which like everyone works on everything? Because of the microservices, like yet another thing is like we're on the monorepo, which has it's its own kind of worms and problems and issues. If you're going with the microservice architecture, you have to remember that there always going to be dependency between the systems. Like those systems has to talk to each other. They somehow have to exchange information. So you have to have a stable APIs. You have to have some way of communicating between each other, like between them. So you have to take into consideration this thing as well. Like I'm not gonna tell you go with the microservices because like everyone is doing this. It has really to be well-defined idea, well-defined, expectations why you want to go to the microservice architecture, because there a lot of things can go wrong. And yeah, it's really complicated topic, to be honest.
Thank you very much. I think the latency would be the biggest thing. In my case, I created like 6 microservices. It's good we didn't start it with just an architecture. Maybe we'll just redraw it.
Yeah, that's the thing. Like, you start small. You don't have to divide the whole system into, like you don't have to build a single application for a single API. Go small. If you have a problem, you don't really know how to divide these tables, how to divide the database, don't divide them. Put them together as a separate, like as a single entity in some place. The nice thing, like if you're gonna go with service mesh, any kind, Istio, Linkerd, whatever, the thing is that by having a service mesh available in your microservice infrastructure, you have an option of dividing. If you have a single API, we have api.fast.co, and then you have a slash API slash v1 slash something. By having, for example, like we are using Istio with the Istio ingress gateways, so it means that any traffic going to our infrastructure goes through that Istio pod, which has a logic inside, which basically tells if you have that API endpoint, instead of going to monolith, go to that another service. Because of that functionality, because of that system, you can really narrow it down where exactly your request should go. And by having a single API host name, by single domain, you can divide this traffic into multiple systems, multiple applications. I don't have example for it, but yeah, like this is one of the way how we're using Istio, and really how we're using Envoy, because we didn't yet migrated that whole configuration to Istio. But using prefix for the gRPC, you can specify that prefix go to that service, that prefix go to another service. So you can start small, like you can start big by having 6 multi-services which are micro, like which are big services. They are not micro. But because of that, you can easily divide them. And then by seeing, okay, I'm seeing that the service for managing, students is more used than the service, like the part of the service used for managing teachers. So because of that, then you can start dividing the service yet more. You can extract anything about the student, managing the student records and all of that. You can put this on a side as a separate unit, as a separate application, and then even you can use Istio or some other service to route the traffic. That, okay, instead of going to that super service managing all of those entities, I can then send only information. If you're trying to access the student API, you can go to that smaller version of the system, this new microservice. So don't try to create a smallest possible microservices. Start with the macro scale, not micro.
Thank you.
Right, I still have permissions, and I had one more question for you. With regards to latency and drift, what
Mm-hmm.
I know a few of the causes. Like obviously there's network latency, there's the time in between services, there's the time it takes to make a database call, the time for it to do its processing. I want to know, especially with the drift and latency, what types of latency and what systems, what processes are causing those, the things that you are looking for.
So we started with the simple problem. We had Nginx ingress controllers, which because of the security reasons, they were locked into that they can only be accessed from the Cloudflare. So we started from there. That like we have to figure it out something what's going to be internally in the infrastructure and what's going to allow us. So going from AWS cluster to the public internet to the Cloudflare, we by removing that requirement, we decreased up to 90%, even on some APIs up to 95% of the latency. But the new things which come up, there is so for us, the front-end services and some services used internally for communication with other external, for example, systems. They are implemented in different languages. So then the problems comes up the problem of connection pooling. And this is the problem which we really like trying to solve right now by having Istio. Istio uses the sidecar, and with Istio we are able to configure the sidecars to do connection pooling, which means that whenever application A calls application B, keep connections open for up to 5 minutes to be reused. The biggest problem especially with the MTLS, it's a TLS handshake. You have to go 4 times back and forth to be able to establish connection. So we had a majority of our clients, like we started as a company providing a checkout solution for people using BigCommerce, which is a vendor providing option of having store in their infrastructure. And it was really easy for us because they have a single API, which they have in the URL, in the URI, you specify a store ID, and because of that, you can send an API against different stores. So what we've done on the Istio, we configured connection pooling. So we are able to reuse those SSL sessions. Because of doing this, we decreased the latency of the connections to that system by 35%. So there are some things you can do, but it's like really depending. But yeah, because like the simplest thing which Istio does provide you is just the connection pooling. But there are other.
Cool. It's cool to hear that you're tuned to the point where the TLS negotiation is 35%. Like that's a kind of a testament to how fast this is. That's really cool.
Yep. Yeah, that's the really nice thing from like the company presentations perspective, because like when it first rolled out Istio, we were telling, hey, we decreased latency of the service to service communication by 90%, which affected clients' checkout process by 30% around. Then we had a problem with connections to the BigCommerce, to those stores. Like they were taking just way too much time. So we enabled this connection pooling, and yet another time we decreased the latency by 30%. So there is a really huge gains you can get from using a service mesh. Everything depends on the company. Like if they are okay with going with service mesh and they gonna allow you to try and do those things, there are really huge gains to get. We can't hear you, or I can't hear
Rookie mistake.
you.
It was going to happen eventually. Just figured it might as well just do it now at the end. So yeah, I really appreciate the information in this, and I think I speak for everybody who is attending tonight. We had one question. Francisco asks, "Are you hiring?" So I don't know if there's a place that you can be contacted at, or that you want to share for that kind of thing. But or if anybody has a follow-up question that they could ask, I don't know if you want to share your a place where they can contact you, or if they should just go to the FAST website.
Yeah, so of course we're hiring. The simplest way to contact me, I can, where is the, so my email address is lubosz@fast.co, where I can send a message to, can I send the message to everyone?
Yeah, I think you can try it. Yeah, try it in the chat there. It's kind of finicky sometimes on this platform.
Yeah,
but I got to figure that out.
Okay, I have a chat here. So yeah, you can always contact me. The keyboard does not work. Cool. So that's my company's email.
And then can everybody see that out there in the chat? Is that popping up out there? Let me do this too. Awesome. Great. Thank you.
Yeah, that's my private email. You can find me on LinkedIn. I'm not really a Twitter person. Probably I should start Twitter account before, but I never really used Twitter. I'm in Tampa. Right now I'm in Sparkman Wharf. Our office here in Tampa is in Sparkman Wharf. So if you want, we can always meet. Send me email, send me invitation, message on a LinkedIn, send me invitation to, to friends on LinkedIn. We can get a hold of each other. We can meet. I'm here always. I moved here 4 months ago, and I'm planning to stay here. So
yeah,
that's probably going to be the easiest.
Tampa kind of has that effect. You move here, and next thing you know, you're here. So welcome to the area, by the way.
Thank you.
I wanted to I just wanted to throw this out there. And again, thank you so much. The Pinellas Tech Network, which is this meetup night, is sponsored by Geographic Solutions. We're also a software development company, and we are in Pinellas County. So please look us up as well. You can go to geographicsolutions.com. And the Pinellas Tech Network, you can find us on Meetup or LinkedIn. You can find us on Eventbrite. In December, we have a meetup that's going to be on Bitcoin, blockchain, and NFTs. So please look out for that. And there's also an end of the year tech extravaganza coming up at Armature Works, which is going to be just like a Techapalooza of all these different Tampa Bay meetups coming together. So look out for that as well. There will be some information that you can see on meetup.com, LinkedIn, so on and so forth. So without further ado, Lubosz, thank you so much for being here tonight and for sharing this information. Thanks everybody for coming. I really appreciate it. And to everybody, have a great evening. I'll see you soon. Thank you.
Thank you so much. Bye-bye.
Bye, everybody. Thank you.